Hi guys, our lesson today is about complete a square. So if we have a general equation like ax squared plus bx plus c, how can we complete a square for this equation? So the idea comes from two formulas. The first one is m plus n the whole thing square and equal to m squared plus 2mn plus n squared. And then the second formula is m subtract n, the whole thing square, equal to m square subtract 2mm plus n square. So the only difference between two formulas is the plus and minus, the operation plus and minus, and then it appear right in front of 2mn. Okay, so and then in order to complete a square, we need to divide them into two cases, then it's easier to follow. So the first case, we have the coefficient a equal to 1. So in this case, then the general formula becomes x squared plus bx plus c. So how can we do complete square for this equation? So we already have a first term x. Okay, so in order to find the second term, we notice we only need to pay attention to this one, to the middle term bx. Okay, and we don't care about x because x is already the first number we need to fill in the formula. We only need to find the second number, and the second number, in order to find it, always take b here and then divide by 2. Okay, so after you have the second number, okay, the second number here is n. Okay, it is n, and the first number m is x here. Let's say x here. Okay, so after we have the second number, but we need another thing, is the square of the second number. Okay, and the square of the second number is a b squared over 4, right? So somehow we need to add b squared over 4 into the equation. Okay, so let's try. We need x squared plus bx and then plus c, and then we need to add b squared over 4 into the equation to make n squared appear. This one is n squared. Okay, so that we can complete a square. Okay, and then the moment you add b squared over 4 into your equation, then you need to subtract it as well, so that you don't change the original equation, because our original equation is only this one. Okay, only inside the circle. So whatever you add more, you need to subtract it right away. So and then it will not change the value of your original function equation. Okay, so now after we add it, so now we only need to switch the position of this one and this one. Okay, so this one to here plus c, this one to here, and then subtract b squared 4 and is here. Okay, so we just switch the position a little bit, because it's because all of them are additions, so we can move around. Okay, so now we already have this one. Okay, so this one is a complete square. Okay, you can write it as x plus b over 2, the whole thing square, plus c subtract b square 4. Okay, this one you don't need to care about. It's just a, you know, free coefficient. The thing you need to care about is this one. Okay, and why it is a b over 2, I already explained above. Okay, and if you want to compare with the formula above, so this one is or I can write like this, so it's easier for you to follow. I can write like x squared y, because why this one becomes the formula x plus b over 2 square. So it come from here. So we have a b times x times b over 2 plus b square over 4 plus c subtract b square over 4. So this one just the whole thing here, they are just equal each other, right? Because the 2 times b over 2 is just b, right? And it is a bx. I just change the position, you know, of xb and a little bit. That's it, because it is multiplication, so you can move it around, change the position. Okay, so now this one you compare with the formula m plus n square above, you see exactly the same, and then we have x plus b over 2 square, and then plus c subtract b square over 4, and that's done. So that's the idea of this case of how to do a complete square. We'll go to example, and then you can see it easier. Okay, example, now if we have a x squared plus 2x plus 3, so how can we complete this one? How can we do a complete square for this one? So we also follow the rule above. So here we always start from this. Okay, we need to find the second thing. So actually not from here, we only focus about this number. Okay, we don't care about x. Okay, because x is already the first variable, first number, so we only care about the rest. And in order to find the second number, so we need to divide this one by 2, and we have is equal to 1, right? So here is n. Okay, so we have n square equal to 1 square equal to 1. So it means you need to add 1 in this equation. Okay, but the moment you add 1, you need to subtract as well. Okay, plus 1 subtract 1 right away, so that you don't change the original 1. Okay, so now you just move around, because you know n square equal to 1, n is 1 and n square equal to 1, so you just move it around. You must just move 1 here, and then plus 3 subtract 1, so your 1 is here, your 3 is here, and subtract 1 is here, right? Yeah, so after you do that, you already determine what is x and what is m, what is n, and then you just write here x is always m. Okay, so we don't need to talk about that, just talk about n. So here n is 1 square, and then here this one we have 3 subtract 1 equal to 2. So that's done. That's the first example. The second example, this one is a little bit more complicated. Let's say plus the 4. Okay, so for this case, no, not say 4, plus 6 maybe. Okay, so here we already have an m square. M square is x square. M is x, so don't care about x. So just care about how to find n, okay? And always start from the numbers stick to x and then divide by 2, then you will have a n, okay? This one is n, okay? And so n squared equal to 25 over 4 because you square 5 over 2, right? So after you already determine n squared, then you need to add it to the equation, okay? And the moment you add it to the equation, you need to subtract it right away, okay? So that you can keep the original equation unchanged, okay? And then you move it around a little bit. So because this one is n squared, so move it over here, okay? And so properly, you just change the thing a little bit, right? Yeah. So here you already have the square here, okay? And you already determined above n is 5 over 2, so just write it right away, okay? And this one you can do calculation and it equal to negative 1 over 4, right? You just do common denominator, so this one become here. And it is own for addition. So how about subtraction? So subtraction is also the same because if you look at the formula above, so m plus n square and m subtract n square. So the only different thing is the sign, you know, plus or you know subtract, you know, in front of 2mn, right? So now we'll do one example about subtraction formula. Okay, let's say you have x squared subtract 6x plus 11. So how can we complete this one? So it is a similar thing. So we already have x squared and x here, so it is m, right? So we don't care about that, just care about how to find n. And just start from here and then break it down into, so it's a 3 and this one is n, okay? So we have n squared equal to 3 squared equal to 9, right? And after we after we already determine n equal to 3, n squared equal to 9, then we must add n squared into your equation, okay, to make n squared appear. And the moment you add n squared 9 into here, then you need to subtract right away so that you don't change the original equation, okay? And then you will move around a little bit, right? Just move it around because they are just subtraction and addition, so just move it around a little bit, okay? Then here you see this one, you have a because you already determined above n equal to 3, so just write right away. And here is x subtract 3 square because you have a subtract sign here, okay? Because you have a subtract there, so that's why your formula becomes subtract, not plus, like previous examples. And then here it just become 2. So it's a pretty easy, right? Very straightforward. There's a no tricky thing here. So now we'll go to case 2. So case 1, you have a equal to 1. So now we have a different from 1, okay? So your formula is ax squared plus bx plus c. So for this case, you need to do one more step. Is you need to factor out a, okay? So to make the coefficient of x squared become 1, then you can do it easier. So when you factor out a outside, then inside you have x squared here, you have a b over a x, and you have a c over a, right? you don't know, because we don't have a number a, b, c here, so we don't know b can divide by, is divisible by a or not, and c is divisible by a or not. So we just keep the general formula like this. And similar here, we have n equal to b over 2a. So n square here equal to b square over 4a square, right? Because like I said, you just divide, you know, the thing, whatever, stick to x here by 2. And then you get n, right? And if you, you know, if you, what is n? Then n come from this formula, okay? That's what I mean about n, okay? Okay, so here, so after you got this, it means you need to bring this one into your equation, but because all your new thing here is inside bracket, so you need to bring this one inside bracket, okay? Not outside like the case a equal to 1. So here we have a x squared plus b over ax plus c over a, and then you need to add with n squared, and n squared is a b squared over 4a squared, and you, the moment you add it, you need to subtract it right away. So and then your original equation does not change. Okay, so now it's similar to similar above. You need to move it around a little bit so that, yeah, you just move it around a little bit so that you can make the formula appear. You can make it look the same like the formula m plus n, the whole thing square. And here you have x plus b over 2a, because you already determined n equal to b over 2a above, square, and plus c over a subtract b square over 4a square. And now if you want to bring, because you see c over a subtract b square over 4a square, they are just you know, the remaining. So if you want to make it outside, then you only need to bring it outside your bracket by multiply a with this one and then a with this one, so it become plus c subtract b square over 4a, right? Because a times c over a equal to c, a times c over a equal to c, and then a times b square over 4a. After you simplify, it just become b square over 4a, right? So that's the, so we already finished the general form. So now we'll come to the example, okay? So example, let's say you have a 5x squared plus 10x plus 20, something like this. So you can see here our a is not 1, it is 5. So it is case 2. So you need to factor it out to make x squared coefficient is 1, not 5 anymore. So just a factor 5 out. Whatever coefficient you know, stick to x squared, just you know, factor it out. And inside will be x squared plus 2x plus 4, right? And now you need to find n. N also come from here. So n equal to 2 divided by 2 equal to 1. So n squared equal to 1 squared equal to 1. So after you do some, you know, take note outside like this. So just bring n squared in, okay? Okay, bring n square in, and the moment you bring it in, you need to subtract it right away so that your original equation does not change. Okay, now you also do like all other example above. Just you know, move the number a little bit like this, so that you can make the it similar to the formula. Okay, so 5 over x plus 1 square plus 3. So this one is just a 3, right? And you don't want to see 3 inside the bracket, okay? You don't want, you want to separate it a little bit. So just, you know, multiply this one out, okay? And done. So that's your answer. So it's a pretty easy, pretty straightforward. Just find n or find the second number. You can say something like that by divide, you know, whatever stick with x by 2. So and then square it to find its square, and then throw it into your equation. And the moment you throw it in, you need to subtract it right away, okay, to make the original equation does not change. Okay, and then just follow the formula, and then you got the answer. Okay, so that's the end of this lesson. So next time, next lesson we will apply this one to function, you know, to a parabola function. Okay, so now we will stop here. Bye bye.